Okay, I think it was quite an interesting magic show, isn't it? Yeah, I think the way they made it into a magic show. And I think they really summarize all the important points of this topic. Yeah, which I thought will be useful. Yeah. Any questions with regards to the video, Money? No? Okay, great. Okay, so if that's the case, then we'll just move on with our questions. I think there are 20 questions in total. So after 10, I'll just give you a short break before we continue, okay? So the diagram shows a magnet brought near a glass block. What will happen to the glass block?
It will not move as the glass block does not get attracted or repelled by the magnet.
Very well done. Yes, correct. I think by now you're able to give explanation already because the glass is not a magnetic material, so it will not be attracted, right? Okay, great. This one not an issue. I think you got it right. Next one, Melissa places a magnet close to a copper coin. What is likely going to happen to the coin?
The copper coin will not move as copper is not a magnetic material.
Very good. So what are the magnetic materials again?
School is not cool steel, iron, nickel, and cobalt.
Very good. Well done. Okay, iron, nickel, and cobalt. Yeah. And a lot of times students get confused with copper. Copper is actually not a magnetic material, right? It's a non-magnetic material. So therefore the answer is D. It will just remain stationary. It will not move. Yeah. Okay, question 3. Which of these is not a magnetic metal? Nickel? Yes? No?
Nickel, cobalt, and iron are magnetic. Copper is not.
Yeah. Okay, quite similar. I think first few questions are usually testing you on the different types of magnetic materials. Okay, more or less, if you have the concept, you'll be able to answer. Now it's a plastic. I think they made a mistake here. This one should be a plastic block instead. Okay, so I guess this is the same thing, right? With plastic, it will not move, isn't it? Because plastic is a non-magnetic material. Answer is B. Yes. Okay, great. Next one. Which one can be bent easily without breaking? Yes.
It's a towel because a towel is flexible.
Okay.
But has nothing to do with magnets.
Yeah, you're right. Actually, this question falls
It's
under
on
materials.
materials.
Yeah, I think when they were sorting out the questions, maybe there was a mistake at the back-end side. Yeah, so we'll feedback that to them. Yeah, you're right. It's actually materials. Is when we talk about something can be bent easily without breaking, actually we're suggesting that it is flexible, right? We are talking about the flexibility. Okay, flexibility of the material. So of course, glass is not quite flexible. The one that can really bend is towel. Okay, even if you were to wrench it, it will not break, basically. Yeah, so it's actually C for this one. Actually, metal spoon also, I mean, it doesn't bend easily. That's why it does not fulfill this criteria. Okay, all these three actually do not bend easily. Yeah. Okay, next question. An object P was attracted to a magnet as shown in the figure below. Object P is made of
Iron, because
Yes.
wood, plastic, and rubber are non-magnetic.
Very good.
They're not even metal. They're non-metal also.
Yeah, and even if they're metal, sometimes not all metals are magnetic as well. Yeah, so this one is non-magnetic materials. Very good. Okay, answer is A. Yeah. Okay, so basically the first 5 questions are all on first 6 actually, because one of them is materials. This question is also on the magnetism, right? Whether is it magnetic or non-magnetic. So which of the following can be attracted?
C, steel.
Very good. Steel. Very good. Wonderful. Okay, then let's move on to 8. Now let's take a look at 8. I think 8 is a bit more challenging. Okay, we did one question, I think last week, which is very similar to this. Basically, diagram 1 shows the mass of magnet M, which is 20 grams. Now, if you notice, this one is actually lesser. If it's lesser, means that magnet M is being pulled upwards a little bit in terms of force. Okay, so a force is applied, and what force is it? It's actually a pull force. Because the force is either a push or a pull. You probably gonna learn that in primary 5. Okay, a force is a push or a pull. Yeah, a force is a push or a pull. So in this case, since it's lighter, it means that a pull force is exerted on the magnet. Okay, so when it's pulled, it means that object Y and magnet M, what's happening between them? You have a call, is it, mommy?
Huh?
Someone called you? Someone called you?
No. It's just I'm plugging in the charger. That's it.
Oh,
I'm on the
okay.
bed. It's a bit high, so it's hard.
Oh, okay. Okay. So, right. So it is a pull force. So definitely it's either A or D. Now you will have to consider whether is it copper or steel.
It must be steel because copper is non-magnetic. It's steel is magnetic.
Well done. Yeah, if it's not magnetic, there will not be any interactions at all. Yeah, so it has to be steel, and the answer is D. Okay,
So that
that's
means
that.
if it's a pull force or a push force, it affects its mass.
It does, because if let's say they are repelling, if let's say assuming object Y is a magnet, and let's say north and north, so it will repel instead of pull. So it will be like that, right? It will repel. So it's a push force. And when that happens, this is probably not 18. This is probably like maybe 22 or above 20, because there's a push force exerted on the scale itself. Yeah. So that's the reason why. Okay. Yeah. Any questions with this? Yeah, I think once you get it, right, once you get the concept, any questions, they can just phrase it about the same way, you will be able to answer. Yeah. Okay. So we'll just practice, but I can tell it, I think you have improved quite a lot in terms of this topic. You have not done this in school, right? It's a new topic, right? Yeah, so I think you actually grasp the concept quite fast, which is something good. Okay, now let's take a look at this question. Wants to find out, whenever you see these 3 words, what comes after is always the aim of the experiment,
I learned
right?
this in P3 already. What does
Yeah. Oh, you mean the to find out, is it?
No, in magnets we learned everything.
Oh, you learned it in P3. All right. Yeah.
I told you we learned it in semester 2. We
Oh,
finished.
okay. Some schools do it in P3, some schools do it in P4. Previously, our plan is to have it in P4 for our curriculum, okay, because like I said, we have a curriculum to follow. But then after that, this year, the syllabus just changed. So it's from 2023 syllabus, it's confirmed that magnet is a P3 topic. Yeah. But then again, because prior to this, we were following the old syllabus. Then again, for your batch, right, you will be the last batch doing the old syllabus. Yeah, you will be tested on the old
Yeah,
syllabus.
even for the math in my school, the books actually changed. The P1s, P2s, P3, all level got to use the new books. But my class said we are the last batch to use this old books, and then they're gonna change to new.
Yeah. So
But
I guess
but I like the math syllabus so much. It's so funny and
the
friendly.
old one, is it?
Yeah, it's like some monster type, like My Pals. It's so nice.
But you'll be tested on the old one, so you don't have to be too concerned about it.
Yeah,
Yeah.
it's just same topics.
Yeah. Seems like your batch undergoes a lot of changes, right? After the batch after you. Yeah. They always change the syllabus every maybe 8 to 10 years. They will make some changes. Yeah. They can't change it like every year because every year means it's quite disruptive in terms of like the lesson planning and all. So they always change about 8 to 10 years. Correct. And they can't be changing textbooks all the time as well. Yeah. Okay. So here we have the aim. The aim is the number of coils around the iron nail. Now this one has to be the change variable. Okay, the number of coils of wire around the iron nail will affect the strength of an electromagnet. So this one is the measured variable. Okay, so which two setups should Timothy use for his investigation? Let's see, which two setups should Timothy use for his investigation? The change variable is the number of coils of wire.
Set up P and R.
If I were to use P and R, it's possible. Yeah, because
And also
same
S and Q. Also S and Q.
Q and S. But is there a Q and S in this option?
No, so it's obviously P.
Yeah, that's right. Actually, you're right. Q and S can work also because there can only be one change variable in an experiment. And in this case, the change variable that we will like is the number of coils. The battery should stay the same for both setups so that we can make a fair comparison. Okay, so I think this one is quite, I mean, it's not that straightforward, but I think if you read carefully and understand how an experiment works, it will be fine. This is an experimental design question. Okay,
That's very easy and fun. Very
which one?
easy.
It's
Very
easy, is it? When you do
All the
experiment.
All the questions except for question 8 is easy.
Oh, yeah. I think you did well for this time around. Was it too easy? Maybe I should set more difficult questions.
No, it was because these questions came in my last year workbook and also test, like these questions. So
Yeah.
basically, so much.
Which I think okay, the thing
I
about
think there's an error here. For non-magnetic, they said safety pin. They never told that it's a the safety pin. There's also iron, steel. How can I know?
Yeah, I do agree. They should have specified what key and what thumbtack. Yeah. Okay. But then again, I think what we know for sure is that I think safety pin is one that should have been in the magnetic. So which one has been wrongly classified? Okay, it's most likely safety pin and what is not magnetic here on the left-hand side?
The brass button, because they're not even a metal. They're non-metal. Let aside that they're magnetic.
Actually, brass is actually an alloy. An alloy is made up of a mixture of metals. It's not a pure metal. Okay, it's made out of like copper and something else. Okay, let me just double check. So
Like-
why do they make brass? Why do you think they make brass?
Because maybe there's two like different types. Maybe there's also non-magnetic metals inside.
Yeah, okay, you're right. So actually brass is made of copper and zinc.
Yes, copper is definitely not. So yeah. Copper and what?
Brass, copper and zinc. And then you've heard of steel before?
Yeah. Iron?
Actually, iron is a pure metal, but steel is not. Do you know that steel is also made up of two, it's made up of carbon and iron, actually.
Carbon dioxide?
No, it's not dioxide, just carbon plus iron. Like stainless steel pots, steel window and all this, they are actually made of carbon and iron. So because there's an iron in them,
What's carbon?
carbon is another element. It's a non-metal, but because it's just a filler, mostly steel is made of mainly iron. Now, the reason why we want to create alloys, these two are example of alloys, basically. So alloys, like I said, is a mixture of metals. Why do we need to create mixture of metals? Because certain metals properties are not so strong or not so malleable, not so flexible. So the reason why we created mixture of metals is because we want to make the properties even more suitable to perform certain function. Okay, So steel is an